The fax machine. It transmits documents remotely. It may come as a surprise, but the fax machine does not send text or images. It sends electricity. The fax machine transforms documents into electric signals so they can travel. And how exactly does the fax machine transform documents into electricity? Simply by lighting them. Okay, but how does it work? The fax machine, the keypad, the feeder tray, the receiving tray. Between the two, a stepper motor that drives rollers, and an optical reader. Finally, the wire connecting the fax machine to the outside world, the telephone lines. When a document is inserted into the feeder tray and the number of the destination fax machine is dialed, the document, moved along by rollers, passes over the optical reader. The optical reader projects an intense green light, which reflects off the document, back to the reader. The document ends up in the receiving tray. A copy of the document in the form of electrical signals is transmitted through the telephone lines to a destination fax machine, which prints it. And voila, the copy has been sent. But to see how the fax machine converts a paper document into electric signals using light, we gotta break it open. The first step for the fax machine is to get the document to the optical reader. A stepper motor drives the rollers, which moves the paper along. This type of motor is super precise. Depending on the transmission mode, it can move the paper forward in tiny steps, hundredths of a millimeter at a time. That's important because the optical reader analyzes the document line by line. 28 light-emitting diodes, or LEDs, are positioned along the length of the optical reader. Their job, to emit an intense green light, which hits the surface of the paper and is reflected back to the reader. The reflected light is captured by a row of tiny sensors, nearly 2,000 of them. But it's that reflection of light that's the key to the operation of the fax machine. The LEDs produce a monochromatic green light. That means it only has one wavelength. In short, it's an extremely pure green light. When the green light hits a perfectly black surface, that surface absorbs all the light, and nothing reflects back to the sensors. When the green light hits a colored surface, the paler the color, the more light reflected back. The darker the color, the less light reflected back. Pure colored light makes it possible to evaluate exactly how bright that surface is, no matter what color it is. And that's the sensor's job. These sensors are made of semiconducting materials. They have the rather remarkable ability to transform light into electricity. The more light a sensor receives, the more electricity it produces. That's how each dot along the document's surface is transformed into electric current. Low voltage if the dot is dark, higher voltage if the dot is paler. And voila! These variations in current are now the electrical representation of the original document. Once processed by the fax machine, these electric signals are sent through the phone lines to the destination fax machine. The fax machine. To send a document remotely, it lights it up using a pure colored light, and transforms the reflection of that light into electric current that can be sent and received in an instant. Brilliant. Next